Section 5.7 is about rational exponents. As you see here, we can have something to an exponent that's a fraction. And when you follow the logic through this way, you end up seeing that the 1/2 and a 2, if you multiply those, you end up getting a b to the first power. What the logic behind this is really saying is found here in this key concept. And it's saying that when you have a fractional exponent, that's like taking the nth root. So if I have something like x to the 1/4, that's the same as taking the 4th root of x. Or if I have 3 to the 1/2 power, that's the same as taking the square root of 3. So we now have this relationship between fractional exponents and radicals. It really helps us simplify rational exponents. Let's look at some down here. If I have a to the 1/4, that's the same as saying the 4th root of a. Those are the same thing. And x to the 1/5 is like saying the 5th root of x. Here, let's go the other way. I'm given a 3rd root, and what does that look like using an exponent? Well, that's going to be y to the 1/3 power. And the 8th root of c is really c to the 1/8 power. So here's another key concept that says when you have a fractional exponent, the top number in that fraction leads to the exponent on the base, and the bottom number in that fraction leads to the index of the radical. Here you see an example. Since you're dividing by 3 in the exponent, that's really a cube root of an 8 squared, or you can take the square and put that on the outside of a cube root of 8. Another quick example would be something like this. The 2 means squared, but the 5th, the over 5, means I'm taking the 5th root of 32. Now you could say 32 squared, or you could say the 5th root of 32 and then square that answer. To me, that one's actually more helpful because we know the 5th root of 32 is just 2, and then when you square it, you get 4. So let's see if we can evaluate these expressions. I can't have negative exponents, so this is rewritten as 1 over 16 to the positive 1/4 power. Well, the 1/4 power is another way of saying the 4th root. Does that help me? Is 16 something to the 4th power? And the answer is yes, it is. It's really 2 to the 4th power. And when I take the 4th root of something to the 4th power, I get just that thing. So answer here would be a 1/2. Next example, I know the 3 is a cubed, so I could make this something cubed, but it's going to be the 5th root of 243. Now I wonder if 243 is something to the 5th power. Try it in your calculator if you'd like. When I take the 5th root of 243, I get 3, and then we have that cubed on the outside. 3 cubed is 27. One of the keys when dealing with radicals and exponents is that if the expression is written in radicals, leave your answer in radical form. If it's written using exponents, leave the answer in exponents. So here we have x to the 1/5 times x to the 7th. When you multiply bases, you can add exponents, so we can be adding 7/5 and 1/5 to get x to the 8/5. Over here, it can't have negative exponents, so I'm going to rewrite this as 1 over y to the 3/4. Now that may look like it's an okay answer, but 3/4 really means the 4th root. And we cannot have radicals on the bottom, and this is actually a radical, so we have to rationalize this. The way I'm going to rationalize it is I'd like this to be a 1. I don't want a 3/4, I'd like it just to be a 1. So how can I do that? Well, I can multiply by y to the 1/4 on the top and the bottom. Because when you multiply bases, you add the exponents, and 3/4 plus 1/4 is 4/4. So this is really y to the 1/4 over y to the 4/4, or just 1. And that's how I'm going to leave my answer, because I could say the 4th root of y, but because I started with exponents, I'm going to leave my answer in exponents. If you're asked to simplify expressions with radicals and with exponents, these are the conditions that have to be met if it's going to be simplified. no negative exponents, no fractional exponents in the denominator, no complex fractions, and the index must be the smallest as possible. So here I'm going to try to simplify this. Right now I know it's going to be 81 to the 1/8 power if I just change it into exponent form, and then 3 to the 1/6 power. Now this would be a lot easier if I had the same base, if the 3 and the number on top was also a 3. Luckily we have an 81. And if you recognize 81 as 3 to the 4th, this can be rewritten as 3 to the 4th to the 1/8 power over 3 to the 1/6. Well, power to a power means multiply. So I can make this 3 to the 4/8, which is just going to be 3 to the 1/2. So follow me along when I do that. The bottom is still going to be 3 to the 1/6, but the bases are the same. So now I can divide this having the same base. And when the bases are same, what do you do with the exponents? You subtract them. So really we have 1/2 minus 1/6 in my exponents. Well, I need a common denominator, so I'm going to multiply this by 3 over 3. This is really going to be a 3/6 minus 1/6, which is a 2/6, which reduces to 1/3. So that's what the exponent is when I divide these bases. So my base is a 3, my exponent is a 1/3, and now I should rewrite that using square roots because I started the problem with square roots. So this is really the cubed root of 3. A couple more examples to simplify. I see a fourth root, and if I were to break these up separately into the fourth root of each one of them, I then could rewrite this using an exponent of 1/4. So I'm going to take this 3, or this 9, make it a 3 squared, and then take that to the 1/4 power, because that's what the fourth root is. So I end up with 3 to the 2/4, multiplying 2 times 1/4, which is 3 to the 1/2. So that really helps me simplify that a little bit. Here, fourth root means 1/4, but it's already a z squared to the 1/4. Again, multiply the exponents, so you get z to the 2/4, which is z to the 1/2. Well, that's nice because 1/2 really means square root. So this is really the square root of 3z. The square root of 3 times the square root of z is the square root of 3z. Last one, 1/2 exponent really means the square root, and I'm going to write it this way because I think having the square roots might be easier for us to see what's going on. We have to rationalize the denominator using the conjugate idea. Root m minus 1 is the conjugate of root m plus 1. Oops. The top, I have the same that are being multiplied, so we're going to use a perfect square trinomial idea. I'm going to take the square of square root of m, which will give me an m. And then I'm going to take minus 2 times the square root of m minus 1. If you don't know how I got this, take the top and FOIL it and simplify, and that's what you'll get for your numerator. The bottom, since those are conjugates, we take the first term and square it. We take the last term, square it, and we put a minus sign in the middle. This would be a fine answer, but we started with fractional exponents, so I need to write the final answer using fractional exponents. So instead of taking the square root of m, I'm going to have to say m to the 1/2 power. Everything else looks okay, and that's my solution.